Hi everyone. In this video, let's look at how do you identify what kind of MLO capability your client device is supporting. So this is a question being asked, like how do you identify whether client is multi-link multi-radio or multi-link single radio, or sometime whether client supporting enhanced multi-link capability. So we will look at all these particular options very briefly, and then I will focus on one particular client using a Qualcomm FastConnect 7800 adapter and show you how you can verify that client capability. Now, in multi-link, there are two main scenarios. One we call multi-link single radio. That means your client device have only one radio, but sometime if it is advanced radio, they can basically break into two sort of a lower capable radio. So that's what we call enhanced mode, where you can change the physical radio into logical radios, software point of view. Now, mainly, your one option is called multi-link single radio. So now, as I said earlier, if you can convert that single radio into lower capable radios, then you can have some enhanced capability. So that mode of operation is called enhanced multi-link single radio. Now the other side of main classification is what we call multi-link multi-radio. Now in here you have an option called multi-link multi-radio with simultaneous transmit and receive. That means your device have multiple radio. Those two radio can operate same time independent to each other. So typically access point falls into that category. Why? Because access point should be able to transmit and receive each radio like a 2.45 GHz, 6 GHz independent. So that way APs will always fall into that category. If your access point is supporting Wi-Fi 7, so that AP should be able to independently operate those three radios. Now there's another mode called multi-link multi-radio, non-simultaneous transmit and receive. Now another mode called enhanced multi-link multi-radio, or if you have a capability of radios to change into multiple lower capable radio by firmware level, that mode is called enhanced multi-link multi-radio. Now where this information goes in sort of frame exchanges. Now there's a one element called multi-link element. So in this multi-link element, you can see here in some example frame capture, you can see there's something called MLD capability. That means multi-link device capability. So inside that multi-link device capability, we will have certain information. Now, how do you identify whether it is single radio device or multi-radio device? Now, for that, we will use a specific information field called maximum number of simultaneous links. So typically this is indicating how many simultaneous links can be used. So especially AP is always advertised with the this value higher than 1. But the client perspective, client will when the client sending association request, client will disclose what is its capability. That means can client support traffic going across two different links simultaneously, or client can only do across one link. So now this value is sometime the way IEEE define this value. So now in here it's always think about if a value being 0, that means client indicating he can transmit traffic across one links. It's like a n-1 kind of value. So if this value is 0, that means client is telling he can transmit data across one link. So now in the example you can see here, it says maximum number of simultaneous links is 2. That means if this is coming from a client telling I can pass traffic across 3 links. So that means definitely this is a multi-link, multi-radio kind of client. In that way, the key takeaway is if this value is 0, so that client will be either MLSR or EMLSR, single radio client. If this value is greater than 1, that means it's a multi-link multi-radio. So it can be any of this value, but why I highlighted this in yellow, now today's context, there are no vendors supporting non-simultaneous transmit receive, EMLMR also very rare. So these are not part of the Wi-Fi 7 certification program. In that way you can safely ignore these two modes. In that way your client devices or AP has to be fall into one of these categories. Now then how do we know whether these devices supporting enhanced multi-link capability? Now, if they are supporting enhanced multi-link capability, now there's another element called EML capability element. Now, in this particular capture, you can see other than the multi-link capability information, you have a EML capability information. Now, MLD capability information there. Addition to that, you have something called EML capability. That means this client supporting enhanced capability. But now how do we know whether it is a EMLSR or EMLMR? You can see that enhanced multi-link capability element, there's a 1-bit value called EMLSR support. And also you have something called EMLR-MR support. That means these both bit cannot be 1. So if this is 1, that means he is a multi-link single radio with enhanced capability. So if this bit 1, that has to be one of this client. That means he is supporting multi-link multi-radio with enhanced capability. Now as I said, like there are very rare, you find this kind of client today. Okay. So now that way, now access point of view, all Wi-Fi 7 access point, if it is certified from Wi-Fi Alliance, they check whether all the access points supporting MLMR, STR kind of support. Now client devices point of view, it is mandatory to support MLSR mode. That means multi-link single radio. So now if the client is advanced client, he can support enhanced capability as well. Now as I said, probably we will do a separate video to go into the individual kind of mode and see how the traffic flow goes, like each of these 3 main type of modes. But now for this particular example perspective, what I'm going to do, I have a Meraki setup. So it has been set up like I have went for 320 megahertz in 6 gigahertz and 80 megahertz in 5 gigahertz and channel 120 megahertz in 2.4. So you can see I have configured SSID for AKM value 8 SAE and group dependent hash AKM value 24. So both GCMP 256 and CCMP 128 has been enabled. So now these are not manually you go and configure. When you enable this AKM value, ideally your access point vendor should advertise both encryption cipher. Broadcast cipher point of view, we will use the lower value. So now the adapter I'm using is Qualcomm FastConnect 7800 adapter. It's plugged into my Dell desktop. So I'm using that client for testing. Now AP being used is 9178 with Meraki firmware 32.1.6 firmware. Now what I'm going to do is let me just go to my Meraki dashboard and show this to you. Now at the moment, let me just make sure there are no, I didn't connect any particular client. You can see there are no client at the moment. So now in here, so if I go to my Windows client, so here's my Windows client. Now if you type netsh wlan show interfaces, now you can see I have a couple of adapters. I have a Netgear Wi-Fi 7 adapter. I have Intel B 200 adapter, and also I have this Qualcomm FastConnect 7800 adapter. Okay, so now what I'm going to do is I will go ahead, but before go ahead and connect the client, let me take the packet capture, so that way we can always have a capture available to us, because sometime I will select my access point, download, let's make it 300 second, or let's say make it 600, but 300 should be okay, 5 minutes. Now I will name this capture Meraki, let's say Qualcomm 7800. Now this is in this particular setup, all tri-band being enabled. I will say MLO, let's say capture number 1. Now let's go ahead and start capture. Now let's connect the client. Now in here, when you have multiple adapters, you should see I have renamed these. I can easily understand. Otherwise you will say Wi-Fi number, interface number, maybe 1, 2, 3 like that. So I select the Qualcomm interface and my SSID is MRK-P. So now I will connect the client. Now you can see client got connected. So now if I issue the show interface command again, now this particular time you can see, he established connection link ID 2, which is 6 GHz, link ID 0 is 2.4. Now it's got connected and using GCMP 256, and now you can see the data rate value showing as a 5.7 gigabits per second. So I want to make sure, still it is showing that particular one. Okay. Now if you look at the MCS index table, and if you search 5764, let me control F, 5764. So you can see 5764 you can achieve with 320 megahertz. And if you go back here, this should be 2 spatial stream, MCS index 13. Okay, I'm doing a 4K count because I'm close to the access point, my client device, so I'm getting that data rate value. So ideally now, if I am using a 80 megahertz in 5 gigahertz, I should be able to get 1.4 as well. Okay, so now ideally, if this client capable of doing 116 5 gigahertz as well, so total value should be 5.7 plus 2.8, almost like a 7 6 gigabits per second kind of value. But you can see client telling, at the moment is still data rate point of view, this value. So now in the Meraki, let me just make sure I show you the Meraki as well. Now let this capture going, assurance client. Now you can see here, now if I click this client, now you can see here it shows client is showing 6 gigahertz and 2.4. Now ideally in the packet capture, now you can see it's a again this output we cannot tell it's a multi-link multi-radio or multi-link single radio. Why? Because you can see traffic is basically sending across one link. So in that way, even a multi-link single radio as well, this is quite possible. In that way, there are no direct indication. Ideally, it would be good if you can see that client capability. Sometimes in Cisco 9800, you can clearly see the client capability there. So now let me just check whether the capture has been finished. Stored captured. you can see that capture time has not been, like still it is gray. That means still not available yet. So let this finish. Now ideally, like what you need to do is, like you have to generate some traffic and see whether other links being used. Now you can see here still, now you can see that capture has been finished. So let me just download. I will provide this capture as well. In that way, no problem. So now you can see its capture size is a bit large. That's okay. I will go ahead and open this capture in Wireshark. Now here's the setup of my Wireshark. When I open that, so now you can see, typically if you want to finding out client association, you just go to management, association request kind of frame, you filter. Now in here you need to pay attention for our SSID. If you remember, it's called MRK-P. Now you can see some after some time you can see MRK-P. Now in here, now this is the client association. If you want to check the client capability, this is the frame you need. So now before go there, I will just MRK-P. Let me just show some beacon frame. Now MRK-P, this is 2.4. Now let's pick some 6 GHz, SSID, because I want to show you some capability of the what's beacon being advertised. Now in here, AP should have a multi-link element. You can see multi-link element is there. Now in the multi-link element, AP, if you go for the common info, now in the common info, you can see AP telling AP has both capability. Okay. So now in the multi-link capability, if you expanding, now AP telling he can do 3 simultaneous links. I mean 2.4, 5 GHz and 6 GHz. He can transmit, receive across all these 3 links. And then the AP also saying he's have a enhanced multi-link capability as well. So now what capability AP got? For the single radio client, AP can support enhanced multi-link single radio operation as well. But sometime now this is what AP being advertised. Now the real sort of interesting value you need to look for, the client association. What's the client telling? What kind of capability client got? That way beacon frame, sometime you will have some higher capability. In this particular example, in the multi-link scenario, AP supporting multi-link multi-radio. Also in the single radio operation, AP can support enhanced multi-link single radio as well. But that's why we're going to go for association kind of filtered traffic. Now I am basically look for my SSID. Now before, let's see, now we can see only one association. That means this is a stable association. There are no reconnections. Now only this one you can see filtered for that, and you go for multi-link capability. Now in here, if you look the multi-link capability, you can see under common info, you can see only multi-link device capability is listed, no EML capability. That means this client is not supporting enhanced multi-link capability. But now to finding out whether this is a multi-link single radio or multi-link multi-radio, you have to expand this and look for this information here, maximum number of simultaneous links. So this client tell I can support one here, one mean, number is 2. So keep that in mind. You have to add one more to get the simultaneous link value. It is to the, like a n-1 kind of concept. So always if this value is 0, this is guaranteed client is a single radio client. But anything other than 1 indicating client has a higher capability. Now in this particular case, client tell he can do 2 simultaneous links. That means in the sort of a previous example, if I go back to the client now, ideally this particular client should be able to send traffic across these both of these links when they're connecting to, when you have enough traffic, you should be able to load balance across both links. So in that way now, FastConnect, Qualcomm FastConnect is a multi-link, multi-radio. Like now, if I go back to the presentation, now in the multi-link, multi-radio, now there's let me just go back in here, few capabilities. Now the question is whether it is any of these modes or multi-link, multi-radio with STR capability. Now you can remember we discussed these modes are not part of any certification. These are not being implemented by vendors. In that way, if you see this value is greater than or 1, that indicating definitely that client supporting multi-link, multi-radio, simultaneous transmit and receive. So now the question is, do you really need your client to establish multi-link across these 2 bands? Because this band will not give any higher throughput. Okay. In that way, now if you really want to gain some higher throughput, probably 5 GHz and 6 GHz maybe the ideal band you need to go with. Now by default in this kind of my setup, they establish a multi-link, multi-radio capability using this. Now what I'm going to do is actually I will do one more test in here. So what we are going to do is in my SSID, let me just go ahead and I want to disable 2.4. Why? Because I don't want my client to be connected multi-link operation. Let me just go ahead and disconnect this client. I will disconnect this client and then my SSID point of view, I will edit this setting. For this one, I will disable 2.4 MRK-P. In that way, I am advertising these 2. Anyway, in this particular scenario, they should go with MLO across these 2. I would like to check, is the data rate point of view, is there any difference there? Okay, so that's what I'm going to do. Now, again, let's go ahead and take a packet capture. This access point, download, and 300 seconds is good enough. And I will use MLO number 2 in this particular time. 2.4 and 5 2 point has been disabled. So I start the capture. I go ahead and now this particular time again I go ahead and connect the client. Without any problem it got connected. Now I use the same command. Now you can see here now I am establishing a link across 5 GHz, 80 MHz bandwidth and 320. But still you can see this value still remains same. That means whenever you establishing a 320 MHz kind of connectivity, unless there's a traffic, exceeding or large volume of traffic, I don't think it, showing here the aggregated bandwidth. But, by looking at this particular value, I can tell, the maximum client is supporting is 5.7 gig. Okay. So then you can achieve that using 320 MHz bandwidth. But if I reduce this to 160, now if you look at the table here, if you have a 320, you will get a 5.7 gigabits per second kind of data rate value. But if I reduce it to 160, you will get a 2.8 gig from there. Okay. Now I would like to do the one last test, reducing this channel width to 160 and see what data rate value it shows here. But now in here you can see it only showing still 5.7 gig. That means pretty much is sending traffic across this one. Now if I go back to the Meraki dashboard as well, just to leave it running, I just want to share the client detail here this time. Now in this time you can see it shows the 6 gigahertz channel 5. You can see it's active, kind of link 1 is active, and this one 5 gigahertz channel 149, you can see no SNR value being showing. That means there are no active kind of traffic passing through. So even this particular time as well, if I take the packet capture, you should be able to see client is trying to do MLO connection, multi-link, multi-radio. So now, we'll wait for this capture to be finished, 5 minutes worth of capture before disturbing the client. Yeah, let it finish, and then what I'm going to do is I will reduce this channel width to 160. So you go to RF profile and this value, I will go and change this 6 gigahertz value to 160. Okay. So once I save and apply, so ideally in this particular scenario, I would like to see the data rate value, what I see in the client perspective. Now in this particular scenario, expectation is right now it is showing 5.7 gig because 320 megahertz bandwidth can directly provide that value. Now if I go to 160, if it's supporting multi-link, multi-radio, it should basically aggregate these two values, 2.4, 2.8 plus 1.4, roughly like around 4.2 gigabits kind of value I should see. Now let me just make sure intelligent capture. Let me save this setting. When it may be disturb the client, that's okay. Stored capture. So you can see this capture has been done. I will download that. Now if I go to Wireshark and open that capture, before we go to the third one, MLO 2, in this particular time as well, you can see only one association request, MRK-P. Now in here, if I look for multi-link element, so you can see it has a common info. It has only one capability, multi-link capability. Now in here, simultaneous link is 1. I mean he's supporting 2, multi-link, multi-radio. Now per station profile indicating which other band he want to bring for the MLO connection. If you look at this one, capability station info section here. Capability, you should confirm this is 5 gigahertz, link ID 1, that's another indication you can find it out. But like a HT capability, VHT capability, extended capability. Now by using this, you can see VHT capability, you can identify this 5 gigahertz kind of thing. The link ID 0 typically in Meraki 2.4, link ID 1 min 5 gigahertz. Okay, so now this is telling client, hey, I would like to establish multi-link multi-radio 6 gigahertz and 5 gigahertz. So now for the last testing, I have changed client like to 160. Now let me just disconnect this and do one last capture, because I would like to check what's the client capability. New capture, access point, download. Let me just take 120. That should be good enough. MLO 3. In this particular case, 6 gigahertz 160, 5 gigahertz 80 megahertz. Now I will go ahead and connect the client. In this particular time as well, it was get connected. Now you can see here, it's basically still showing me the 2.8 gig. Okay, that is typically data rate you will get across one 160 megahertz kind of channel. You can see 2.8 gig. So in here, I would expect it to, if client supporting those two simultaneous, he will tell, hey, I'm supporting 4.2, but I'm not sure, there's a, but at least I have to check whether, even I would, this is showing 2.8 gig kind of support. That does not really, telling me the aggregate throughput, if it is a MLMR client, simultaneous transmit receive, I should be able to aggregate this throughput. Okay, but in here you can see the client is telling not like that. That's something I would like to test further, but you get the idea. Okay, so now in here as well, if I take the packet capture, there's no difference this time. Let's this 2-minute finish. Same like earlier, it will tell he's supporting multi-link multi-radio. A simultaneous link should be value 1, indicating he can pass traffic across 2 links, but appear to be in the client perspective as well. It does not really show me the aggregated throughput value. That's something interesting. I would anticipate it to see something this value plus 1.4. Let me just double confirm my LS Wi-Fi. Yeah, we already including MRK-P. So we should see both. It is being advertised across both band. So now both band being advertised, but client is always giving me the data rate value of a single link, 2.8 gig. Okay, so hopefully you get the idea. How do you differentiate, which kind of band they're supporting? Now, before we finish, let me open this file as well, just to show you. Now I need to pay attention for this one, because that's what our client association. Now in the multi-link element, common info, multi-link capability, you can see here is listing value 1 here. That means this is a multi-link multi-radio, simultaneous transmit receive. So now then sometime Wi-Fi 7 can operate without MLO. So that means in that kind of scenario, you may not see multi-link element. Okay, so you may see EHT capability, but there are no multi-link element will be there. In that way, if your Wi-Fi 7 client just operating on non-MLO mode, so then probably you will not see the multi-link element. That's keep in mind as well. In that way, always they will not go for a MLO kind of connection. They are quite possible. Your client can completely, like a traditional 11, without multi-link, client can establish connection across a 6 GHz link. In that scenario, you may not see a multi-link element, but you will see a EHT capability element in the association request. So I hope this make useful to you, identifying which mode of multi-link operation. So as a key takeaway, remember we are using 3 main mode: multi-link single radio or enhanced multi-link single radio. So like a Intel B200 client fall into this category, enhanced multi-link single radio. So these clients are typically not very common. The Qualcomm FastConnect adapter is one I found. Recently Ubiquiti introduced another client. Other than those 2 clients, I don't really know much of the other client types supporting that. That way, this is the mode you will get aggregated throughput, because you can transmit, receive across many bands. So okay, hopefully this video is useful to you. I'll see you in another video. Until that, take care.